Okay, so we were doing particle kinematics. So initially we studied rectilinear motion, and in rectilinear we studied rectilinear continuous and then rectilinear erratic motion. Then we went towards curvilinear motion. So we started analyzing curvilinear motion in Cartesian coordinate system by using XYZ coordinate system. And in that we studied one subtype of curvilinear motion, that was projectile motion. So in today's class, what we are going to do, we will analyze curvilinear motion again, but today we will not consider Cartesian coordinate system. Instead, we will use a new coordinate system, that is normal and tangential coordinate system. And in this case, the components of motion that we will be having, it will be normal and tangential components. After this, in the same class, we will study another types of coordinate system, which is basically polar coordinate system. And if we want to consider that polar coordinate for 3D, so that will become cylindrical coordinate system. We are already aware of about these coordinate system, but how we can apply, how we can analyze motion, how we can do our kinematic analysis in these coordinate system, we will look into it in today's class. Okay, so okay, so in today's class, what we need to do, we are basically we will basically study curvilinear motion and in different coordinate systems. So first, let's consider the curvilinear motion in normal and tangential coordinate system. And definitely, if you are using anti-coordinate system, so the motion it can have normal as well as tangential component. Okay. So before going into it, if you recall your previous class, in previous class while using Cartesian coordinate system, so while studying curvilinear motion, we consider that if we have a particle, it follows this curvilinear path as shown in this diagram. And if we want to analyze its motion, or if we want to analyze the position of particle at any instant, for example, the position of particle at this instant. So to represent this position, we need basically a position vector. Position vector is basically a vector that represents the position of particle at any instant. And for defining this position vector, we basically require three variables: x, y, and z. Now let's say during a time t, or during any time, or during any instant, the particle move from this location p to p dash, right? So now to define this new position, again we have to use a position vector. So let's say in this case the position vector is r bar. Okay, and definitely to define this position vector, we need three variables in case of Cartesian coordinate system, that is x dash, y dash, and z dash. So what are basically x, y, z, or x dash, y dash, z dash? This is basically the distance of particle from origin in x direction, in y direction, as well as in z direction, right? So let's say during a very small interval of time, or during a very short interval of time, or we can say um, within an instant, or we can say like when the time t approaches to 0. So in that case, any process that we have, that will become instantaneous. So let's say during a short interval of time, the particle p, or the particle that was having initially point p, it moves to p dash. So the displacement that it cover, we know that displacement is basically a final position minus initial position. It will be given by r bar minus r, right? So let's say r bar minus r is given by this dr. Okay. So initially we were having the particle position, which was defined by position vector r, and then we have particle position, which was defined by r bar. Okay. So the distance which it covers, or displacement which it cover while moving from p to p dash, let it be dr. And as we know that the velocity is basically the time derivative of displacement, so we can have velocity as time derivative of displacement. And since over here we discussed that the time interval is very short, our time t approaches to 0, so this means we were having instantaneous displacement. And definitely if you consider instantaneous displacement, so you will also be having instantaneous velocity. So that's why instantaneous velocity is given by this equation. If you put values of position vector over here, so you will get components of velocity, and the single dot basically represent, that is x dot, y dot, and z dot. This represent derivative of x component, y component, and z component with respect to t. Okay, if you take time derivative of velocity, of instantaneous velocity, you will get instantaneous acceleration. Okay, which is also equal to double derivative of displacement. Okay, if you want to put the values of r, if you want to put uh, r values of r, which is basically x, y, and z, so in that case we will get acceleration in terms of its component. And remember, this double dot, that is x double dot, this represent the double derivative of x variable with respect to time. Similarly, y double dot and z double dot, they basically represent double derivative of these variables with respect to time. So in general, the displacement, velocity, and acceleration are all three-dimensional Cartesian vectors. Okay, here we need to recall, and we don't need to forget that, remember, the velocity of particle at any instant, if you are having a curvilinear motion, so the velocity of particle at any instant, for example, if the particle is here or here or here, at any instant the velocity of particle can be given by tangent to the path, right? So in case of curvilinear motion, the velocity of particle will always be tangent to the path. So we need to remember this thing. This will help us in our further discussion. Okay, imagine we are having a curvilinear path, a particle that is following some curve. Let it be this. Okay, and imagine that we are having a 3D curve path. So we can have a 2D curve, for example, like this. This curve is now in 2D plane, and we can also have a 3D curve. So for example, that curve can be like this, right? So now this curve is in 3D plane, or we are having a 3D curve path. Okay, so let's say we are having a 3D curve path. Okay, to analyze this 3D curve path, let's have x, y, and z coordinate system as shown over here. Okay, here we want to derive one conclusion from this curve path. What is that? Let's have a look at it. Okay, this curvilinear motion, if we divide it into small segments, so we will observe that this whole curvilinear motion, it is combination of small segments, and each segment is basically an arc, right? If we extend that arc, so what will happen? We will get a circle. Okay, and that circle will be having some center point, and it will also be having a radius. Let's represent that radius by rho, and the center point by O or O dash. Since already we have O, so let it be represented by O dash, right? So the center of this curve, it will be the same as the center of this circle, and the radius of this arc, it will be same as the radius of this circle. And we usually call this radius of arc as radius of curvature. Okay, again, if we consider another arc, it will make another circle, right? So as you can see, I have divided this whole arc into small segments, and each segment is basically part of a circle. It is a part of a different circle. Okay, so as I have shown over here, it can be divided into small segment. Yes, G, any question?
No, sir.
Okay, okay, it can be divided into a small segment of curves with equal lengths. Okay, now consider we are having this arc. So if you extend this arc like this, so if you continue like this, finally you will get a circle like this, right? Now in this case, the circle that we got, this portion of arc, it is in YZ plane. So that's why we got a clear circle, and it's appear as in circular shape from the front, right?
Yes, sir.
Okay, and one thing we need to remember, that circle is basically a 2D entity. It needs to be appear in a plane, not in space. So we know that circle always fall in 2D plane, right? We can analyze circle in a 2D plane. We never have circle in 3D space. Like if you incline, if you tilt that circle, so it may have different components in different planes, but as a whole, if you consider that circle, So it can be analyzed in a single plane. So what I want to say, circle is basically a 2D entity. Okay. Now if we consider another arc like this one, and if you extend it, we will get another circle. So each circle is basically lying in different plane. For example, if I want to draw plane over here with this circle, so you will identify that the plane over here, it is tilted to both the planes now. So this is basically the plane in which this circle lies, right? Now let's consider this arc. So we will be having another circle, right? So as these circle lies in different planes and we are looking at it from the front, so sometimes it basically appear as circle and sometimes it appear as an arc. So what I want to conclude from all these discussion, that circle is basically a 2D entity, and you can see we were having that 3D curve path, and I have divided this 3D curve path, or I have extended those segments into many circles. And remember, circle rise in 2D plane. So this means this whole motion, this whole 3D motion, it can be like defined as it can be defined as the combination of so many 2D motion, which I have mentioned at the last. This one. Okay. So the reason to define all those things is that now the 3D motion is acting as a sequence of 2D motion, right? So we are having overall this 3D motion, a particle is following this curve, but this curve is somewhere lying in this plane, somewhere it is lying in this plane, somewhere it is lying in this plane, and somewhere it is lying in a plane that is tilted to both the planes, right? So we can say that the 3D motion can be considered as a sequence of so many 2D motions. Okay. So imagine we have a particle at this point, and then it's move and reaches this position. So let's say if this is the arc that the particle follows, so the distance that it covers, that will be equal to the arc of a circle, right? And this arc of a circle will also be having our, okay, give me a minute. Okay, so where were we? Okay, so the distance that the particle travel, it will be equal to the arc of a circle. Okay, so the same thing I have mentioned over here, that each segment ds is formed from the arc of an associated circle that is having a radius of curvature rho and a center O. Okay, at any point on this arc, we can define now a new pair of axes or a new coordinate system. Okay, how we can define? For example, if I want to define the position of particle at this instant, so I can have my new coordinate system, that is anti-coordinate system. Okay, so the t coordinate system, which is tangential, it will be basically tangent to the arc at this point, right? And the other component, which is the normal, that will be perpendicular, that will be basically perpendicular to this t axis, and this n is usually directed towards the center. So this new axis or this new coordinate system, which is having two components, that is n and t, is known as anti-coordinate system. Okay. So for a particle in a short moment, if it travel along this curve path from location P to P dash, the distance travel is basically the length of arc, which is ds on this path, as I have already discussed this thing. Okay, the t-axis, this one, the t-axis is tangent to the curve at a point and is positive. कब आपके पास t axis positive होगा, यहाँ पे mention कर दिया गया, it will be positive in the direction of increasing s. If if you observe increase in s, increase in displacement, increase in distance, so in that case or in that direction t will be positive, right? Okay, and the unit vector that we have along t axis, it is represented by ut. Similarly, The n-axis, it will be perpendicular to t, and it will be positive if it is directed toward the center of curvature. For example, if we have this arc, and if the t-axis, if it is directed towards the center of curvature, so in that case we will consider that n as positive, and the unit vector that we can have along n-axis, it will be given by un, right? So another word, we can say that the positive direction in case of n-axis is always to the concave side of the curve. Is it clear? And the direction, it will be represented by basically the un, which is the unit vector along n-axis. Okay,
Yes, sir.
velocity, if you want to define velocity, so we already know that velocity, it basically depends on the displacement. If you take the time derivative of displacement, so we will get velocity. And we also know that the particle velocity, v has a direction, and how we can get that direction, or what information we have about that direction, it is that it is always tangent to the path, right? And a magnitude, the magnitude of that velocity can be determined by taking the derivative of displacement, right? So as we know that velocity is having two things, one is the direction and one is having the magnitude. So magnitude can be defined by taking time derivative of displacement, and the direction, we can get that by finding the tangent to the curve at that specific point where we want to find out the velocity. Okay, so the final equation that we get for the velocity, it is shown over here. So if you look at this equation, the velocity is basically equal to the magnitude of velocity and direction of velocity. Since velocity is a vector quantity, it is having magnitude, and we know that magnitude of velocity is also known as speed, and this is basically the direction of velocity. So over here we don't have any term in n-axis, right? Because the direction of velocity is given by tangent to the curve. Okay, we can also have proof for this equation, but I think it's not that much important. Still, if you want, so let me know, I can provide that. But in our class, we will not go into that detail. Okay, so ut is basically the unit vector along t-axis. It is giving the direction of velocity. What is basically that p? This is the time derivative of displacement, and it is also represented as s dot. Now, if you want to find out the acceleration, so acceleration is basically the time rate of change of velocity. Give me a second. Okay, so now let's look at the acceleration. So acceleration is basically uh, the time rate of change of velocity, or another word, it's basically the time derivative of velocity. So it can be given by this equation: acceleration is equal to dv by dt, and as we know that from previous slide, that velocity is basically equal to magnitude into direction. So now we are having two terms in this equation, that is v and ut. Okay, so if you want to take derivative of these two terms, you need to use the product rule. So according to product rule, it will be derivative of first into second, and then second into derivative, sorry, derivative of second into first, and then second into derivative of first. Okay, so based on this, you can take the derivative. So as I know that, as we know that v is equal to magnitude into direction, and this magnitude, it can be given by this equation. So this is basically from the previous slide. So again, if you go into the details, if you do those necessary proof, so finally what you will get, you will get this equation. Mean the acceleration that you have, it will be having two component, one along the t-axis and one along the n-axis. So if you recall our previous lecture, in previous lecture, what we defined that the direction of velocity at any instant, it can be given by tangent to the path. ठीक है, किसी भी पॉइंट पे अगर आप वेलोसिटी की डायरेक्शन निकालना चाहते हैं, तो वो क्या होगी, वो टेंजेंट टू द पाथ होगी. ओके, बट इफ यू गो थ्रू द वीडियो रिकॉर्डिंग ऑफ प्रीवियस लेक्चर, वहां पे हमने डिफाइन किया था दैट acceleration it is neither tangent nor perpendicular to the path, so it will be somewhere in between. So अगर कोई कंपोनेंट आपके पास इन दोनों के दरमियान होगा, this means that acceleration would be having t component as well as n component. So that's why in this equation we are having two component. Acceleration is basically equal to the tangential component of acceleration and the normal component of acceleration. And again, acceleration is vector quantity, so tangential component is having magnitude and it is also having direction. Similarly, the normal component is having magnitude and it is also having direction. Okay, now how we can get this magnitude? So this magnitude can be obtained by taking a derivative of velocity. Okay, so at is equal to dv by dt, and normal component magnitude, it can be obtained by using this equation, which is v square by rho. Now what is this rho? This rho is basically the radius of curvature. The radius of curvature. For example, particle is following this curve, and at this instant, or if it is following this curvilinear path, so if you want to find out the position of particle at this instant, so what you need to do, you need to find out this radius. So this radius is basically rho, right? If the particle is at this location, so now at this location, this might be the rho, right? Again, how we can get these equation, the final equation which I'm discussing, again, the proof is there. If you want to go through a proof, it may be there in your book, and I can also provide it to you. But in class, we will discuss only the final outcomes of these equation or of these proofs. Okay, so if you get at, if you get the other component an, so and if you want to find out the final magnitude of acceleration, you can get it by using this equation. Okay, now the two important cases that we need to discuss for acceleration, uh, let's have a look at it. Okay, before going to it, kindly give me a few seconds. I have to check something else.
Yes, sir.
Okay, so the two special cases for acceleration while using anti-coordinate system. Okay, let's look at the first one. Okay, what is acceleration? If we want to define acceleration, this is change in velocity with respect to time, right? So we know that velocity is having two things. One is the magnitude and the other one is the direction, right? So if there
Yes.
is change in magnitude, we will be having acceleration. If there is change in direction, still we will be having acceleration. And if there is change in both, again we will be having acceleration. But if the magnitude as well as direction remains constant, so in that case we will not be having any acceleration, right? So let's consider one more thing. If we have this curve, so this curve will be having a center point like this, and this one will be the radius. So you can see the radius is very small. If we have curve like this, so the radius will be bigger, right? Okay, if we have curve like this, so again maybe the radius may be out of the screen. Okay, and if we have a straight line, if we have a straight line, so for straight line the radius, it will be how much?
Infinite.
Infinity, right? So if it is infinity, so imagine if a particle is moving along straight line, if a particle is moving along straight line, means its direction is not changing, it is following a straight line, and its magnitude is changing, its magnitude is
Changing.
changing. That is, for example, initially the velocity was 2 meter, then 4, then 5, then 6, then 7. So now our initially if the velocity was 5 and then it's reducing, so still there is change. So if a particle is moving in a straight line, the direction is not changing but the magnitude is changing, so we will be having acceleration. And if you look at the previous slide, in this one rho is equal to infinity, so this term will become, this whole term will become this one, what, 0.
Zero.
Zero. Yes.
Okay, and if there is change, what this dv, this is basically change in velocity, change in velocity magnitude. If there is change in magnitude of velocity with respect to time, so we will be having this component, right? So when you put this thing over here, this term will become 0 and the total acceleration, it will be equal to the tangential component only,
Yes, sir.
right?
Yes, sir.
Okay, now let's consider another case. If we are having, if we, okay, let's read the first one. If the particle moves along a straight line, then rho will be infinity, and from the previous the equation on previous page, n becomes 0 and a will be equal to 80, that is equal to time derivative of magnitude of velocity. So we can conclude the tangential component of acceleration, it represents the time rate of change in magnitude of velocity, right? The tangential component
Yes,
of
sir.
acceleration, that represent the change in magnitude. Okay, now imagine we are having a particle that is having a constant velocity magnitude, that is having a constant speed or constant velocity magnitude, right?
Yes,
But
sir.
its
Yes,
direction
sir.
changes. So is it possible that the magnitude is constant but the direction changes? Can we have a case like
Yes.
this? Okay, anyone, if you
In,
want to give me an example.
in circular.
Yes, for example, you are driving a car and you are maintaining a speed of, for example, 50 km/h, right? And the road which you follow, it is basically changing its direction, means it's having so many curves. Or if you are moving with a constant speed of 30 km/h and you are continuously moving in a circular path, so now the magnitude is constant but direction is changed. So the first term, this is constant, there is no change in it, but there is change in the direction, right?
Yes, sir. Yes, sir.
Okay, so let's look at this equation. The change in magnitude is how much?
In a circular path.
Yes, in circular path, the change in magnitude is how much?
0,
0. So this term will become
0.
0.
0. Okay. So magnitude is constant, and definitely any path that it follow, it will be having a certain radius at that instant. So we
Yes,
will be
sir.
having some value of an, and by putting this term equal to 0, we will be having this term an. So a will become equal to an.
And yes, sir.
So from this, what we can conclude? We can conclude that that the t component is basically caused by the change in magnitude of velocity, and the n component, that is basically caused by the change in direction, right?
Yes, sir.
Okay, so now let's look at the second paragraph. If a particle moves along a curve with a constant speed, then in that case this term will become 0, and a will become equal to an, which is equal to v square by rho. Therefore the normal component of acceleration represent the time rate of change in the direction of velocity. Since an always act towards the center of curvature, so this component is sometimes referred as centripetal acceleration. You know that centripetal force and centrifugal force, right? So
Yes, sir.
Yes, sir.
the acceleration caused by the centripetal force, that is basically known as centripetal acceleration, or the acceleration which is directly toward the center of circle, it is known as centripetal acceleration. Okay, so let's look at some important notes from the slide that we have covered so far. Okay, in Cartesian coordinate system, we used to have a fixed origin. For example, if particle is following this curve, if you want to define this position, so what you need to do, you need to measure all distances from origin. If you want to define this position, you need to measure all distances from this origin, right?
Yes, sir.
Okay, if you are having anti-coordinate system, in anti-coordinate system, if you want to find out the position of particle at this instant, so in that case we don't have any fixed origin. Rather than our origin, we will set our origin at this position. This one will be our t component, and this one will be our n component. If you want to find out, if you want to find out the the position at this instant, so this will be our t component, and this one will be our n component, right? So in this case, the origin is fixed on particle, and when particle moves, the origin also moves with it. Is it clear?
Yes, sir.
So
Yes,
the
sir.
anti-coordinate system is fixed on particle, therefore moves with the particle. So when describing velocity using anti-coordinate system, the velocity only has one component, and that is the t component. Okay. Whereas in case of acceleration, we have both component, and the at basically represent change in speed or change in magnitude of velocity, and the an, it basically represent change in direction of velocity. And
Yes,
we,
sir.
as we know that velocity is basically time derivative of displacement, or ds by dt. In case of anti-coordinate system, v is having one component, that is vt. So the acceleration that we can use in this equation, that will be basically the tangential component of the acceleration. So as we know that acceleration is equal to dv by dt, since we can have only one component in anti-coordinate system, that's why at is basically equal to dv by dt, right? And if we combine both these equations, what we will get? We will get these equation. So this is basically these are the similar equation which we used to have in our previous classes, and which we gave the name of basic kinematic equation. So these three are basically the similar equations.
Yes, sir.
Okay, we also derived the equation of motions for constant acceleration. If you remember, one for means that the one was s is equal to s naught plus v naught plus half at square, and the acceleration was constant. The other one was v is equal to v naught plus at, and again the acceleration was constant. So now in this case, in all those cases, in all those equations where we have acceleration, so instead of acceleration we will put at, since the velocity term is involved in every one of them, right? So these are basically
Yes,
a
sir.
three equation of motion. Okay, as I have already discussed that an is sometimes known as centripetal acceleration. Why? Because it is pointed towards the center. are it is always pointed to the concave side of the path. Okay, for example, if you are having some curve, if you have some curve like this one or this one, or if you have curve like this one or curve like this one, and if you know about, if you have information about the path, information about the path means you have variable of this point, you have variable of this point, you have variable of this point, or you are having an equation which basically represent this path. So then if you have that thing, then what you can do, you can find the slope of this curve, right? अगर हमारे पास किसी पाथ, किसी कर्व वगैरह की इंफॉर्मेशन मौजूद है, तो उस इंफॉर्मेशन के बेस पे हम क्या कर सकते हैं, उसका स्लोप निकाल सकते हैं, राइट? सो इफ पाथ इज नाउन, if the path is known, means with the help of some equation or with the help of some data, so what we can do, we can find out the slope or dy by dx. If this is y and this is x, so if we can find dy by dx and if we put that in this equation, so what we can find out the radius of curvature at any instant. So if path is known, then the radius of curvature can be given by this equation. So 1 plus dy by dx whole square, and then double derivative of y with respect to x, d square y by dx square, and this is raised to power 3 by 2, this one. Okay, now let's look at an example. An object travel along a curved path. So we are having curvilinear motion as shown over here. This is the curved path. If at point shown its speed is 28.8 meter per second and that speed is increasing at 8 meter per second square. Which point? This point. Point shown is this one basically. The speed is how much? 28.8
8.
meter. Okay, so this means magnitude of velocity is given. And
Yes,
what
sir.
is this? The speed is increasing at, what is this?
8 meter per second.
What is this? 8 meter per second.
Acceleration.
Acceleration.
Okay. So which acceleration? Will it be A, will it be AT or AN?
80.
Why
80,
80?
sir.
Why?
Because direction is
Velocity direction.
we
Let's
have
see
to
again. Okay, the speed is increasing. Speed is increasing means the magnitude is increasing, right?
Yes, sir.
They haven't used the word velocity. So the speed is increasing. This means magnitude is increasing. So this means change in AT
Yes, sir.
or change in VT, which causes basically AT, right? So we have these two things. Okay, what they are asking? Determine the direction of its velocity and the magnitude and direction of its acceleration. So if you recall, very first few classes of our course, engineering statics, and in that course, if ever asked in a question that to find out the direction of vector, so हम क्या करते थे? What we used to do, if this is the vector, so for direction we used to find out its angle with the positive x-axis. यही हम करते थे ना?
Yes, sir.
और अगर वेक्टर हमारे पास यहाँ पे होता, if we have vector over here, so still we used to find out its angle with the positive x-axis, right?
Yes.
Okay, so they are asking for the direction. So let's say let the direction be theta, and theta let it be angle that velocity make with positive x-axis. Okay, what else they are asking? Determine the magnitude and direction of acceleration. Magnitude of acceleration, we already have acceleration, right? Do we have acceleration?
Yes, sir.
Yes,
What
sir.
is the acceleration?
Sir,
What
80
is
or AN नहीं है.
an nahi hai? Okay, so this means if we can get this an, if we can get this an, this means we will take square of this one, take square of this one, add both of them, take square root, so we will get the magnitude of total acceleration, right?
Yes, sir.
Okay, what about direction of acceleration? So again, the angle which acceleration make with the positive axis, x-axis, let it be phi, right? Let it be this angle. So this one needs to be find out and this one need to be find out. And इसको मैं x कर देता हूँ ताकि ये x के. Is it clear?
Yes,
Yes,
sir.
sir.
Okay, now look at this equation, this diagram. Can I find out an? What is the equation for an? V square by rho.
Rho.
Do we have V?
We have VT.
Rho.
And what about rho? Do we have rho? No, we don't
No,
have rho.
sir, we don't
No,
have
sir.
rho.
But do we have equation for rho? This is the equation, right?
Yes, sir.
So what we need in this equation? dy by dx and dy
dy by dx.
by dx double derivative of y with respect to x, right?
Yes, sir.
Okay. Let's look at the diagram. What information do we have in this diagram? The first information that we have, it's the path. We are having path information, right? That this diagram this graph is following this equation. So if I have this y, if I have this x, can I find out dy by dx from this one?
Yes, sir.
Okay, let's look at again in this diagram. Do we have some other information in this diagram?
Horizontal distance 16 meters.
Horizontal distance, yes. So means we also have x distance, right? Means the x distance of this particle from origin. So we have this. So what you need to do, you need to read question again and again to get to extract data from it first. If you extract all data, if you understand, then half of the problem is solved at that instant. Okay. So if we find out dy by dx, if you find that dy by dx, so we will get this row. But did they also ask for double derivative of? We also need dy by dx again, means d square y by dx square, right? If we get these two things, so how we can get it? Find the take derivative, first derivative, then take its second derivative. So we will get these two things. But we are also given with x value, right? So whatever value we get over here, we will put x is equal to 16. Yes, x is equal to 16 in this equation, x is equal to 16 in this equation. So once we get both these things, what we will do, we will put it over here and we will get this row. So once we get row, we will put that row in this equation and we will get an. an हमें मिल जाएगा ना?
Yes, sir.
So we have at now, we have an. Can we find a?
Yes, sir.
Okay, so one of the thing is solved, that is the magnitude of acceleration. Now let's look at the direction. Okay, we know that at any instant, for example, at this instant, if you want to find out the direction of velocity, so we know that the direction of velocity means during a curvilinear motion, it can be given tangent to the path. इसी तरह है ना? It can be given
Tangent.
as tangent to the path. Okay, so means if it is tangent to the path, so this means it is this tangent is neither parallel to x, neither parallel to y. So it should have one component in x and it should have one component in y, right?
Yes, sir.
It should have one component in x and it should have one component in y,
Y.
right? Okay, imagine this one, this component, it is making, sorry, pardon me, because I am drawing it with mouse pad, so it may not be that much clear. So this angle is basically how much? This is 90-degree angle, and the distance between this point and this point It can act as a hypotenuse, right?
Yes, sir.
Okay, so imagine if I take a very, very small segment, a differential segment. So we know that the curve is basically combination of so many small lines which changes direction at every instant. So we can get a very small differential. We can get a very small or a very small, in other words, differential triangle. Okay, the angle over here will be equal to angle over here, right? And that will also be equal to the angle over here. Is it clear?
Yes, sir.
Okay, so if we consider this differential element, okay, so the y-axis will be given by dy and the x-axis will be given by dx.
Dx.
Okay, how can I find out tangent theta? Let's say this angle is theta. This angle is theta. So tangent theta will be equal to what? G. Will it be equal to dy by dx?
Perpendicular.
Dy by dx. Right? Is it clear?
Yes, sir.
And theta will be equal to tangent inverse dy by dx.
Yes, sir.
Okay, so now let's see. For acceleration, we are having this equation. And we know that the at component is equal to 8 meter per second. And the an component is equal to v square by rho. Alright? And we know that rho is equal to this equation. So for that, we need dy by dx. And we know that y is equal to this thing. So take its take its derivative with respect to x. So when you take its derivative dy by dx, you get this thing. Put x is equal to 16, right? So when you put it, what you will get? You will get 1.5 value. What is dy by dx equal to at x is equal to 16 meter? You get 1.5, right?
Yes, sir.
Okay, so tangent theta is, or another word, dy by dx is equal to 1.5, and we know that dy by dx is equal to tangent theta. So tangent theta is equal to 1.5. If you take theta on one side and tangent on the other side, you get this thing, and you will get this angle, right?
Yes, sir.
Okay, so the first thing is solved. The first thing is solved, which is basically the angle of velocity with positive x-axis, right? Now we need one more thing: the angle which acceleration make and the magnitude. So as we have now dy by dx, we need d square y by dx square. So this is dy by dx, this equation, and this is the second derivative. Okay, put x is equal to 16, x is equal to 16. So once you do so, dy by dx become 1.5, and d square y by dx square become 3 by 64. And when you put it over here, so you get rho is equal to 125. So when you put this one in an, in this equation, we already have v, which is 28.8, take it square and divide by rho, so you get this one. So now we have this component and this component, right? Put it in this equation, you get the magnitude of acceleration, right? यहाँ तक क्लियर है
Yes, sir.
जी?
Sir, ये 96 degree का क्या है? 96 degree.
या वो वहां पे तो मैंने भी एक्सप्लेन ही नहीं किया ना, उधर तो मैं गया नहीं हूँ. ये तक क्लियर एक्सेलरेशन कैसे फाइंड आउट हुआ? ओके,
Yes,
नाउ
sir.
लेट्स सी. आई टोल्ड यू कि वेलोसिटी की डायरेक्शन कैसे, इट विल ऑलवेज बी टेंजेंट टू द कर्व, टू द पाथ. बट एक्सेलरेशन के मुतालिक हमने ये कहा था कि ना तो ये पैरेलल होगा, टेंजेंट होगा, और ना ही ये परपेंडिकुलर है. इट इज सम बिटवीन दीज टू. So acceleration always have two components, right? It is, if it is following a curved path, then acceleration will be having two components. One will be along t-axis and one will be along an. So if this is the t-axis and it is also having n-axis, so if you combine these two, so the resultant acceleration or the total acceleration, it will be in between these two. So we have now this value, we have this magnitude 10.4. What else we need to find out? We need to find out its angle with the positive x-axis or its direction. So let's say the angle that it makes with the positive x-axis is this one, right? And let's say the angle is phi. Okay, so if you want to find out this one, so it should be equal to 56.3, which is this theta, right? This angle is theta, right? And let's say this angle is alpha. This is theta and the other one is alpha. So phi should be equal to theta plus alpha, right? Okay.
Yes, sir.
Now if you look at this diagram, this is alpha, right? This angle is alpha. And this component is equal to what? It is equal to 80. What about this one? This one is equal to, this component is equal to an. We have 80 and we have an, right? So can I find out tangent alpha? Can I find?
Perpendicular divided by base.
Okay, so it will be, what is perpendicular?
Sir, 80 an divided by 80.
What is an? What is 80?
an हमने 6.64 divided by 80 जो given है.
ठीक है. और what is alpha? Alpha क्या आ जाएगा आपके पास? Tangent inverse 6.64 divided by 8, right?
Yes, sir.
Okay, so means alpha is equal to tangent inverse 6.64 divided by 8, and theta is from previous slide, that is equal to 56.3. So put that in the equation. When you combine both, you will get this angle. So the angle that acceleration make with positive x-axis, it is basically 96 degree. Is it clear now?
Yes, sir.
Okay. Now let's consider the same motion, the same curvilinear motion, by using another coordinate system, which is the polar coordinate system. So if you remember, at the very beginning of this course, we studied the coordinate system, in which we studied Cartesian coordinate system, in which we were having x, y, and z coordinates are variables. And then we studied polar coordinate, in which we were having two variables, that was r and theta. Remember?
Yes, sir.
Okay. And then we discussed that polar coordinate can be only used for 2D system. If you want to use it for 3D system, we must give it another variable, that is z. So this is radial, this is angular, and this one is linear. So when you have this type of coordinate system, what is the name of this coordinate system in which we have r, theta, and z? G. Cylindrical coordinate system. Very good. Okay. So now let's compare the polar coordinate system with Cartesian coordinate system. Okay, so polar coordinate system versus Cartesian coordinate system. So imagine we are having a particle at any location P. Okay, we want to define its position by using Cartesian coordinate system. So what we need? We need just two variables. If it is 2D system, we need x and y. Now the same position can also be defined by using another coordinate system, which is known as polar coordinate system. But in that case, instead of x, y, you will need two another variables, like not x, y, we will need r and theta. What is r? R is basically the distance of particle, direct distance of particle from the origin, this one, right? And in r theta system, in polar coordinate system, we used to have an origin, we used to have a reference line. हमारे पास एक reference line मौजूद होती है, ठीक है? And if you want to reach out this point, any point, for example, point P, you must move by some angle, right? So to reach from this reference line to point P, we need to rotate, or we need to cover some angular distance, which is theta, right? So this r is basically the distance between the point P and the origin, and this theta, this is basically the angular distance that you need to cover while moving from this reference line towards r, or towards the particle, right?
Yes, sir.
Okay, and we know that if you are having xyz coordinate system, or if you are having Cartesian coordinate system, so the unit vector that we used to have along x, it was given by I, and the unit vector along y was
J.
j. Okay, in case of polar coordinate system, okay, this is r, so the unit vector along this will be in this direction, and since the rotation is in this direction over here, you can see, right? So it can be in this direction, and the unit vector along r axis, it can be given by ur or er, and the unit vector along theta, it can be given by e theta or u theta, whatever is easy to you people. Okay, so now let's look at it. So you see the unit vector along r, the unit vector along theta, the unit vector along x, the unit vector along j. Okay, now what is r? R is basically the radial distance, or the variable, first variable in case of polar coordinate. Theta is basically the angular dimension, or the angular or the second variable in case of r theta coordinate system. Imagine we have particle at this position, and let's say the value of r is 4 and theta is 60 degree. We can also write this theta in other units, that is in radians, and we know that 2 pi radian is equal to how much degrees?
360.
360. So this means pi radian is equal to 180 degree, right?
Yes, sir.
And you divide both sides by 3, so you will get 60 degree on other one side and pi by 3 on the other side. So pi by 3 is equal to 60 degree, right?
Yes, sir.
Okay, so this means theta is equal to 60 degree or pi by 3. So these coordinate can be written as 460 or 4 comma pi by 3.
Yes, sir.
Okay, if you want to write down, if you want to define the same point by using Cartesian coordinate system, still you can do it. How you can do it? For example, this is right angle triangle, this is hypotenuse, this is the vertical, and this is the horizontal. Let this one be x, as it's shown over here, right? This is angle theta. Okay, so according to trigonometric ratios, cos theta is given by base by hypotenuse.
Hypotenuse.
Okay, so it will be cos theta is equal to x by r, right?
Yes, sir.
And x will be equal to
R cos theta.
r cos theta. Very good. What about y? Y will be equal to
R sin theta.
r sin theta. What is the value of r?
4.
What is the value of theta?
60.
Put it over here, you will get value of x, you will get value of y. So you can also mention these position in terms of xy, right? So what I want
Yes,
to
sir.
prove with this calculation, that you can define the position by using any coordinate system. It's up to you कि किस मेथड को यूज करके, किस कोऑर्डिनेट सिस्टम को यूज करके आपका प्रॉब्लम आसानी से हल हो सकता है, वो कम टाइम ले सकता है, ठीक है, और आपको कौन किस किस्म का डेटा गिवन है. सो यू नीड टू लुक एट योर डेटा, दैट द डेटा दैट हैज बीन गिवन टू यू, it is in which form, either it is in some radial or some in angular dimension, or it is given in linear dimension. So based on the data, based on your ease, based on the time of calculation, you need to select your coordinate system, right? मीन्स आप ये सेम
Yes, sir.
एंगुलर कैलकुलेशन आप विद द हेल्प ऑफ कार्टेशियन कोऑर्डिनेट भी कर सकते हैं, बट मे बी वहां पे आपके पास 3 स्टेप की बजाय हो सकता है 15 स्टेप्स रिक्वायर्ड हो, ज्यादा स्टेप्स रिक्वायर्ड हो, ज्यादा कैलकुलेशन, ज्यादा टाइम, ज्यादा मुश्किल हो वो. इज इट क्लियर?
Yes, sir.
I can give you one example. You are already studying your AutoCAD course. So in
Yes,
AutoCAD
sir.
course, the first thing that you basically studied how to put points, right? And for points, what you basically give X, Y values. So initially, you used to make diagram with this, and then in the second step, you introduce another coordinate system, which is polar coordinate system. So in polar coordinate system, if you need to give some angle, what you used to do, you give R, and then you give some angle theta, right?
Yes, sir.
So you can make the same diagram. You can make the same diagram with the help of Cartesian coordinate system. For example, if you want to draw this line, so it is very much easy. Means this is very easy to draw this line by using Cartesian coordinate. Then if you want to draw this line and again this line, okay, so if you are given this angle, you are given this dimension. So this one from here till this point, it is very much easy to draw it with Cartesian coordinate. Then from here till this point, you can do it by using Cartesian coordinate, and the easiest way is by using polar coordinate. If
Polar.
this angle is 30, so what you will do, just R is equal to 2 and angle is equal to 30, you will get this point. Okay, if you want to do the same thing with the help of Cartesian coordinate, so you need to find out this one first by using sine theta and cos theta. This one will become X is equal to hypotenuse into cos theta, so this one will become 2 cos 30 degree, right? And this one will
Yes,
become
sir.
2 sine 30
Two.
degree. You will find this value, you will find this value, and then from here onward for xy you will use this value. So instead of single step, how many steps we have done? We have done 3 to 5 extra steps, right? But
Yes,
still
sir.
our final answer will be same. So it's up to you. Whatever you feel is easy, you will use that coordinate system, you will use that method, right?
Yes, sir.
Okay, now let's again consider a curvilinear motion in Cartesian coordinate system. But let's have the curvilinear motion in 3D plane now, in space, not in 2D plane. Okay, so for example, we have a 3D curve. A particle is following a 3D curve at any instant. The position can be given by using Cartesian coordinate system with the help of three variables x, y, and z, or with the help of position vector, and position vector must have components x, y, z. X, y, and z are basically the distance of point P, or the distance of particle from origin in x direction, in y direction, and in z direction, right? So position vector can be defined in this way. Okay, now if the particle move from this point to another point, so mean its position change, and that change in final position minus initial position, or the change in position, which can be identified by final position minus initial position variable, it is usually given as displacement. And if the displacement, it is instantaneous, so the instantaneous velocity can be given by this equation, right? We can also write the velocity in terms of its component. We can also have acceleration by time derivative of velocity, and we can also write it in terms of its components, right? I think this is self-explanatory. We have explained these
Yes,
things
sir.
so many times. Okay, now let's define the same position by using polar coordinate system. By using polar coordinate system. So let's say this is the reference line. Imagine this is the reference line, right? This is the position where we want to reach. Okay. Okay. So first what we will do, we will define R. Let's say this is our R. This is R. We have defined this R, but still we couldn't reach this position. So what we will do, we will rotate this R by an angle theta. But we are here, still we couldn't reach this position, right? So to reach this position, we need another variable, another distance. And let's say we cover some distance in the z direction to reach till this position. So now we use R, we use theta, and then we use another variable, or we cover some distance in the z direction to reach this position, right?
Yes, sir.
Okay, so the first one that r and theta that was there in the polar, but the z one is an addition one, and we know that when z is combined with r theta, that become cylindrical coordinate system. Is it clear? And cylindrical
Yes.
coordinate system is a 3D system. So every motion in this case will be having three components, right? And each component will be known as cylindrical component. So in case of cylindrical coordinate system, we will be having three cylindrical components: one along r, capital R or small r, both can be there, one along theta and one along z, right? So the unit vector to represent the direction along r is ur, the unit vector along theta will be u theta, the unit vector along z will be uz. And to define the position, we required three variables: r, theta, and z. Is it clear?
Yes, sir.
Yes, sir.
Okay. So the position vector or the change in position in case of cylindrical component, let it be drp. So the instantaneous velocity will be given by this equation. Okay, if you want to write down velocity in terms of its component, so it will be having how many components?
3.
Three.
Three
Which
components.
component? One along r, one along,
Theta. 1 along
and
Z.
one along z. Okay, so this is along r, this is along theta, and this is along z. Now what is ur, u theta, and uz? These are the unit vector along
Unit.
x, y, and z, and it will be having like same magnitude, right? If you combine all of them, it will become, means the total unit vector magnitude will be 1, right?
Yes, sir.
Okay, so the important thing which we need to determine, it is basically the magnitude of velocity or the component of velocity in different direction, that is r, theta, and z. Okay, so again, I will not go into the detailed proof, but I will just discuss the final conclusion or the final result. So VR, if you want to find out VR, what you need to do, you need to take time derivative of r. Okay, if you want to find out v theta, that will be equal to time derivative of theta multiplied by r. If you want to find out the z component of velocity, that will be equal to time derivative of z variable. Okay, so you need to memorize this thing, and it will be automatically memorized to you once you do few problems on it. So VR is equal to r dot, v theta is equal to r theta dot, and vz is equal to z dot. Is it clear till this point?
Yes, sir.
Yes, sir.
Okay. Now what about acceleration? So acceleration is the time rate change of velocity. Okay, and it is equal to a dv by dt. Again, acceleration will be having three components, right? Ar, a theta, and az. Ar is given by this equation, that is r double dot minus r theta dot square. R double dot means double derivative of r with respect to time. A theta is given by r theta double dot plus 2 r dot theta dot, and az is equal to z double dot. Okay, if you are having 2D system, then this term will become 0. This term will become 0, right? So if you are
Yes,
having
sir.
2D
Yes, sir.
system, and if we have r dot theta, if you are given with r, and if you find out r dot theta dot r double dot theta double dot, so we can find out velocity as well as acceleration, right? If you know r dot theta double dot r double dot, these four things: r dot r double dot theta double dot, and definitely it can be identified if we have r. So if we have these things, we can find out velocity as well as acceleration in 2D, because over here we have r double dot, here r and theta dot, r theta double dot, again r dot theta dot. What about this one? We have r dot r theta dot, and this is not there in 2D, right?
Yes, sir.
It's okay. So now let's look at again what we explained few moments ago, that polar coordinates are suitable choice for solving problem. Polar means 2D r theta, right? For solving problems when data regarding the angular position of the radial coordinates r is given, right? So when you need to use, it will be suitable for solving problem when data regarding the angular motion of the radial coordinate r is given to describe the particle motion. Also, some path of motion can conveniently be described in terms of these coordinates, as I have given you example of your CAT course, the diagram that we used to make in CAT. So that was just modeling, just drawing, but we also need we also face similar sort of situation while doing kinematic analysis or kinetic analysis sometime. Okay, so to use polar coordinate, the origin is established at fixed point. So means in XYZ coordinate you are having fixed origin, then in anti-coordinate system the origin used to move with the particle, and now again in polar coordinate system the origin is fixed, right? And we measure r from the origin till that point, and theta is measured with the reference line. Is it clear?
Yes, sir.
Okay. Okay, the theta coordinate, the transverse coordinate, one is known as radial, which is r, and transverse is known as theta. So the transverse coordinate is measured from a fixed reference line to the radial line. And this is the fixed reference line, and if this is the r, so we measure this angle from here till this one, right?
Yes, sir.
Okay, so once r and the 4-time derivative r dot, r double dot, theta dot and theta dot have been evaluated, अभी जो मैंने आपको बताया कि r और ये 4-time derivative अगर हमें मिल जाए, so what we can find, we can determine velocity and acceleration in polar coordinate system, right?
Yes, sir.
Okay, so now let's look at this equation. Look this diagram. Rotation of radially slotted arm is given by this equation where theta is in radians and t is in seconds. Simultaneously, the power screw in the arm engages the slider B and control is this. Okay, so let's look at this diagram. In this diagram, this is the whole diagram, that's the whole system. This whole system, it rotates like this, right? Okay, so as the system rotates, initially if this axis is at this position, for example, if it starts from this position, so how much would be the angle? Theta, yes, but if this object is at this position on horizontal axis, so how much would be theta? Zero. So at time t is equal to 0, theta would be 0. At time t is equal to 1, theta would increase. At time t is equal to 5, theta will increase more, right?
Yes, sir.
This is given by this equation, means theta is equal to this. So if you put t is equal to 0, angle will be 0. If you put t is equal to 1, so you will get the required angle, right? Or the required position at different time. Is it clear?
Yes, sir.
Yes, sir.
Okay, over here we are having a power screw and we are having this system. Now when this object rotates like this power screw, sorry, this object, this B, it slides up or down depending. So you can imagine when it moves here, this object move again. When it moves here, so sometimes it's come near, sometimes it goes away depending on the rotation, right? So mean this is not fixed. It can move downward, it can move upward. If you change its location, it may move upward or it may move downward, right?
Yes, sir.
Okay, so this means r is not fixed. So r is given basically by this equation. At theta is equal to 0, r is given as 0.2. Theta is equal to 1, put t is equal to 1, you will get r value. Similar, then at some other time, again, you put that value of time and you will get your required r value. Is it clear?
Yes, sir.
Okay, where r is in meter and theta is in second, what you need to do, calculate the magnitude and velocity, calculate the magnitude of velocity and acceleration of the slider, means this object. We need to find out the magnitude and velocity of this object, right? When t is equal to 3 seconds, right? So the good thing in this problem is that we are given with theta and we are given with r.
Ready.
So we are given with r and we are given with theta. अभी पिछले स्लाइड पे मैंने कहा था if you are having r and if you find out r dot, r double dot, theta dot, and theta double dot. What we can find?
Velocity and acceleration.
Velocity and
Velocity
acceleration.
acceleration.
वही तो हमसे मांगा गया है. So we have r. Can we find out r dot?
Yes, sir.
कैसे? How?
Derivative लेंगे.
Derivative.
First
Time
derivative.
derivative. How we can find r double dot? Time derivative. Right?
Yes, sir.
Okay. What is t? 3 seconds.
Yes, sir.
Okay. Put 3 is equal to t is equal to 3 seconds over here also, over here also. So these are the value of r, r dot, and r double dot. R3 means r at 3 seconds. Now we have theta.
Yes,
Can
sir.
we find theta dot?
Yes, sir.
Yes, sir.
Can we find theta double dot?
Yes, sir.
Okay. So when you find, put t is equal to 3 seconds. So you will get theta, theta dot, and theta double dot.
Yes, sir.
Right? Okay. Now, what we need to find velocity. So if you recall the previous equation, velocity is equal to r dot and v theta is equal to r theta dot, right?
Yes, sir.
So do we have r dot?
Yes, sir.
Okay, put r dot over here. So this is vr. Do we have r theta dot?
Yes, sir.
Okay, put, we get v theta. So if you get v theta and vr, can we get v?
Yes,
V
sir.
हमारे पास. Okay, by using this one. Take their square, add them, and take square root. Right?
Yes, sir.
What about acceleration? Write down acceleration equation. It required r double dot, r theta dot. Do we have all these things?
Yes, sir.
What about a theta? Do we have all these things? R theta double dot and r dot theta dot.
Yes, sir.
Okay, so find out this thing. If we have these two things, can we find out the magnitude of acceleration?
Yes, sir.
Okay, by using this thing. Right? So if you want to draw its diagram, so remember the velocity in a curvilinear path, it is basically tangent. The direction of velocity is basically given as tangent, right? So the radial one, it can be like this. It can be along r. What is r? R is basically from O to point B. This is r, right?
Yes, sir.
Okay, so this is r, and the other one theta is basically orthogonal. So it will be perpendicular. This is theta, and we know that v will be in between these two, right? So this is basically the required angle. And if you want to find out the exact angle, so exact angle can also be found out by using v theta and vr, right?
Yes, sir. सर इस प्रॉब्लम में तो डायग्राम की जरूरत नहीं थी ना.
डायग्राम की जरूरत नहीं, लेकिन वैसे ही मैं आपको बता रहा हूँ. हो सकता है
Yes,
अगर
sir.
इन फ्यूचर आपसे पूछ लिया जाए, so
Yes, sir.
you can draw it like this way. But in this, if you don't draw, no marks will be deducted. Nothing will be asked. Is it clear?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now let's look at another example. Okay, before going to that example, okay, let's look at this statement first. Due to rotation of fork rod, this is basically the fork rod. This one, this blue color, means it rotate like this. It rotate this way, as shown by this angle, right? And we have this ball inside. We have a slot here, and we have this ball. So as this rotate here, the ball move away from here. This is the path that is traced by this ball, right?
Yes, sir.
Okay. So it comes here, it moves near at this location, it moves at this point till this point. So the motion that it follows, or the shape of motion over here, this is known as cardioid motion, right? And you can see this radius in the position of this ball from the fixed point, it is given by r. So this is not constant now. It is changing at every instant, right? And it is given by this equation, right?
Yes, sir.
Yes, sir.
Okay. So at angle is equal to 0, cos 0 is equal to 1, 1 minus 1, 0. So r will be 0. It will be at this fixed position, right? And
Yes,
at
sir.
this is equal to, for example, cos 90. At cos 90, this one will become 1 minus 0, and this one will become 0.5. So it will be at 90, it will be, the r will be equal to 0.5, right?
Yes, sir.
Okay, these things are not asked in the question, but why I'm discussing this thing, just to get like the practical meaning of this equation के r का मतलब क्या है. ठीक है, ये equation हमें क्या बता रहा है basically. Okay, where theta is in radians, if the ball velocity, okay, let's first discuss this cardioid motion. Let me share my whole screen with you people. मैं आपको जरा okay, can you look at my screen now?
Yes, sir.
Yes, sir.
Okay,
Yes,
now
sir.
see this one. This path, this red path. This is like cardioid motion or cardioid shape. Motion is having cardioid shape. Is it clear?
Yes, sir.
Okay. So this is the one that we have in the question. It is almost similar to this one. Okay. Now we are having R and what they are asking. Let me. Okay, if A is equal to 30 feet per second square and V is equal to 4 feet per second. If the ball velocity is 4 feet per second, ball velocity is 4 feet per second, and if the acceleration is 30 feet per second square, at instant theta is equal to 180 degree, right? What we need to find out? The angular velocity and the angular acceleration. The angular velocity and angular acceleration. So I told you, if we have R, if we find out R dot, if we find out R double dot, right? If we have theta dot, and if, sorry, if we have theta and if we have theta double dot, so what we can do, what we can find? We can find
Acceleration,
velocity
velocity.
and acceleration. Yeah, in this case, the orientation is little different. We are given with this, we are given with this, we are given with this. This means we can find out this thing and we can find out this thing. And what is required? Required is theta and theta double dot, right? Like इसका equation given है ना R का. Is
Yes,
it
sir.
clear?
Yes, sir.
Yes.
Yes,
So
sir.
you can say it's like just the shape change. Shape सिर्फ आपके पास यहाँ पे change हुआ. Okay. So R is given, and what they are asking? They are asking at the instant when theta is equal to 180, right?
Yes, sir.
Okay. So we have R. Can I find out R dot?
Yes, sir.
Can I find out R double dot?
Yes, sir.
R double dot निकाल सकते हैं जी. By
Yes, sir.
taking its first derivative, it will be R
Yes,
dot.
yes,
By
yes.
taking double derivative, it will become R double dot. Put theta is equal to 180, so you will get value of R, R dot, and R double dot, right?
Yes, sir.
Yes, sir.
Okay. If you recall, V is equal to,
R dot.
no, V is equal to VR square plus V theta square.
Yes,
Remember,
sir.
what is VR equal to? R
R
dot.
dot.
So it will become R dot square. What V theta is equal to?
T dot square.
R theta dot, right?
Yes, sir.
So R theta dot square. Let's verify it. R theta dot, right?
Yes, sir.
Okay. So if I put these values over here, do we have v?
Yes,
v
sir.
है हमारे पास
Yes, sir.
Yes, sir.
4. Okay. Do we have r dot?
Yes, sir.
Do we have r?
Yes, sir.
So the only unknown which we have, it is
Theta.
theta dot.
Theta dot.
So this one will be solved, right? Then what about acceleration? Acceleration is also equal to ar plus a theta square, right?
Yes, sir.
Okay. So this is basically the given data. This is r, this is r dot, this is r double dot. The one thing that you need to do, for example, over here now we have two terms, so you need to use product rule for derivation, right?
Yes, sir.
Yes, sir.
Okay, so at theta is equal to 180 degree, put these values over here. Remember, cos 180 is equal to -1, sin 180 is equal to 0. So when you put, you will get r dot and r double dot values. Put it in the equation, that is v is equal to vr plus v theta, both square like v r square and v theta square. Okay, vr is equal to r dot and v theta is equal to r theta dot, as we did in the previous slide. So by solving, we get theta is equal to 4 radian per second, right?
Yes, sir.
And
Yes, sir.
similarly for acceleration, acceleration is equal to ar plus a theta. Okay, ar is given by this equation, a theta is given by this equation, right? So in this equation, now you can see we have r double dot, we have r, we have theta dot, we have r, we don't have theta double dot, we have r dot, we have theta dot. So the only unknown in this equation is theta double dot. So by solving, we will get theta double dot,
Yes, sir.
right? Is it clear to everyone?
Yes, sir.
Okay.
Yes, sir.
Okay, so this is another example from your RC Hibbeler book. So kindly go through this example. It's already solved and it will be easy. You will be able to solve it. But if you feel any problem in it, so let me know. We will discuss it in coming class or somewhere in some other time. Okay.
Yes, sir.
Okay.
Sir, assignment or quiz, is there anything?
जी वो मैं दूंगा वो I will upload it. Okay. Now if you look at the problem sheet, so it is having problem from your RC Hibbeler book and from your JL Merriam book. So these are the problems for NT. This one is for the RT coordinate system. Okay. RT means radial transverse coordinate system. And again, in JL Merriam books, you are having these problems. So I hope these are relevant problems. If you find any other relevant problem, please go through it. And if you feel that any of these problem is not relevant या बहुत डिफिकल्ट है, सो लेट मी नो अबाउट इट. ठीक है, उसको फिर हम स्किप कर देंगे. बट रिमेंबर, दीज आर नॉट द प्रॉब्लम दैट विल कम इनटू योर एग्जाम. मे बी इसमें से कोई आ भी जाए, बट जरूरी नहीं कि ये प्रॉब्लम्स आए. देयर कैन बी स्लाइट मॉडिफिकेशन इन दिस प्रॉब्लम. The problems can be from some other book, the problem can be from some practical scenario, or it can be a self-generated problems. But hopefully, अगर आप ये problems कर लें, so you would be able to get a clear concept and you would be able to solve it in exam in a good way. Okay, so this is the end of today's class. If you have any question, you can ask me.
सर सर नॉर्मल टेंजेंशियल कोऑर्डिनेट सिस्टम में
हाँ.
सर टी ये किस तरफ वैल्यू हम पॉजिटिव लेंगे?
ओके, ठीक है, वैल्यू हम किस तरह पॉजिटिव लेंगे. ओके, ये ऑलरेडी डिस्कस कर भी दिया हमने, दोबारा आपको शो कर दें. ओके. ओके, इट्स गिवन ओवर हियर. अच्छा, ये मैंने ऑलरेडी एक दफा वीडियो में एक्सप्लेन कर दिया. रिकॉर्डिंग में ऑफ कर दूं?
Yes, sir.
ओके,
Yes, sir.
इफ कोई और क्वेश्चन है तो वो कर लें, ताकि फिर मैं इसको एक्सप्लेन कर दूं. ये ऑलरेडी वीडियो रिकॉर्डिंग में एक्सप्लेन्ड है, सो मैं दोबारा एक्सप्लेन कर रहा हूँ. अगर कोई और क्वेश्चन नहीं, फिर रिकॉर्डिंग में ऑफ कर देता.
No, sir, no further questions.
ओके, सो चूंकि ये ऑलरेडी एक्सप्लेन है, वीडियो को लंबा होने से बचा लेते हैं. ओके, इफ यू लुक एट दिस स्लाइड, यहाँ पे मेंशन कर दिया गया दैट व्हेन यू विल टेक t as positive and when you will take n as positive.
सर
So
आपकी स्क्रीन नहीं, सर आपकी स्क्रीन नहीं जला
Screen
रही है.
नहीं.
okay, let me share again. Okay, so now we are having anti-coordinate system when we will take n as positive and when we will take t as positive. So n का तो clear है, ठीक है? N will be considered as positive if it is directed towards
origin.